Hello, everybody. Welcome to another Dapr Community Call. It's number 116. It's January 22nd, and I'm Mark Dijker, one of the Dapr Community Managers. Shout out to Digwit for sponsoring our live stream subscription. We're live streaming to YouTube, Twitter, and our new LinkedIn page, Dapr LinkedIn. So if you're not following that page yet, I highly recommend you to do so. The best place to watch this live stream is, however, YouTube, because when you're watching via YouTube, you can interact with us. You can ask us questions there, and we will definitely share some links as well in the YouTube live video chat. All right, let's get going. What do we have on the agenda today? Well, first, our speaker is Tom Flenner, who will talk about how to use Dapr at DataGalaxy. Then we have a Dapr-powered pizza demo, and for me, it's dinner time, so that makes me very hungry, by James Eastham. Then I'll share something about the State of Dapr survey. It's the last month that you can provide your feedback, and we'll do the regular community show and tell at the end of this agenda. So welcome, Tom.
Hey, thank you, Mark. I will just share my screen quickly.
Yeah, I will stop sharing and you can go ahead.
Hop, tell me if you see my screen, if it's okay for you.
Yeah, it's here. Perfect.
Okay, perfect. So I will start. I will just start by a quick introduction of what is DataGalaxy and who I am. To start, I will also introduce our technical stack and finish on how we use Dapr on a daily basis on the DataGalaxy engineering part. So first, I'm Tom. I'm a software engineer at DataGalaxy. I joined DataGalaxy like 1.5 years ago. I'm mostly doing backend in .NET with C# and some Golang on my spare time. I'm a Dapr enthusiast. I met Dapr first time like 2 years ago during a contract with .S Canada. Big up to you guys if you're listening to us. And I'm also an event-driven enthusiast. So what is DataGalaxy? We can say that DataGalaxy is the industry's first data knowledge catalog, also recognized as a data governance platform. We are available everywhere on the cloud, on the several well-known clouds such as Azure, AWS, GCP, and French cloud provider named OVH for people who know it. We have a massive user adoption recognized by Gartner and G2. This year, we have the opportunity to appear on the Gartner Magic Quadrant to 2025. We can say that we are scanning fast, and we are compatible with multiple data stack. As you can see on the bottom right here, we are compatible with more than 17 connectors for integration on the data stack. As I mentioned, there is a lot of compatibility with external tools such as Power BI, Postgre database, things like that. And we are able to scan our infrastructure system and gather metadata from our company, and also feed our data catalog to empower knowledge. So our technical stack, we have few things here. Mainly for the backend, we are using .NET in the last version with .NET 9. For the frontend, we have something in Angular. Our database is PostgreSQL. We also have Node.js for public API, which is a part of API that is exposed to end user. We have also Kotlin for our connectors that are responsible to gather data and metadata from information system of end user. And we're using also Elasticsearch to perform search document in the catalog. So for the run part, we are available on Azure, AWS, GCP, and we are available at least with almost that is running on Kubernetes thanks to Helm packaging. So our platform is shipped on Helm, and we can deploy it on Kubernetes clusters. So we have some clients that are on-premise and have their own server with Kubernetes running and are able to use DataGalaxy on their own. For the data part, data and AI part, which is something kind of new, we have stuff like Databricks, we have stuff like Python for building cool APIs and using models. We are using VLLM also to manage our model, which is Llama 3. So we are using it for several purposes and features in DataGalaxy. And behind Databricks, we are using Azure Data Lake to handle a huge amount of data for DataGalaxy. So what are use cases? At DataGalaxy, we introduced Dapr like maybe 9 months ago. We are using mainly 3 building blocks. The first one is a service invocation to easy use call between multiple components of our system. We are also using the publish subscribe pattern and building block in order to do asynchronous communication between part of our system, and also the bindings. explicitly the output binding for a specific use case that I will show. During my presentation, I will explain which building block we are using where in our technology, and I will be really theoretical on the aspect on how we use Dapr to handle solution for problems that we have. So for the first problems that we're facing, DataGalaxy is a startup. We are growing fast, and we ended with a legacy backend, which is a little bit a spaghetti code. After several years, we take many shortcuts. The previous guys do a really great job in a short amount of time. We were less people than now. So this is result by a huge technical debt and a spaghetti code, which is hard to onboard and also to understand. So for newcomers, it's hard for them to bring new feature and value in the code base. So we decided last year to switch from legacy backend, which was in fact a big monolith, but not well architectured and not so much pattern in it, to some new fancy stuff, which is modular monolith, and try to just more decouple things and things as module for our feature with some bounded context and stuff like that. So it was a huge step for us to bring more value and be able to be more capable to deliver features and have value for end customer. So for this part, we were seeking too much of the legacy backend as only a huge mess for us and painful to have. But in our end, at the end, we just saw differently and try to use the legacy backend as a toolbox and use the internal APIs that already built to handle specific use case that we have. For example, our meta model is the main core of our business. All things related to meta model are already available in the legacy backend, not such in a good way, for example, but it's already available. So if you want to build something new and fast, with dealing with new value for customer and end user that we have to provide as a startup, we just thought to isolate the legacy backend and start from scratch a new one and migrate during time lapse, feature by feature, inside the modular monolith. So Dapr helped us in the first time to do asynchronous communication between the both component. So we had legacy backend that emit a specific event on action. For example, when you are creating a new entity in our catalog, for example, let's say you are a company that have a glossary, you need to define a business term. This business term handle with an action and an event that we can consume on the modular monolith side to do action. I will go on this later about the first AI features that we brought with Dapr, but we can react on this event and do specific stuff in the new code base. So it was kind of really helpful to bring just a component that is RabbitMQ for method broker and use the easy API of Dapr to do asynchronous communication without bringing too much library and things like that, and using a standard to do that. And also to bring some resiliency policy, dead letter queue, stuff like that, which is really easy to use with Dapr. The second one is the synchronous communication. So for this part, it's the same as the previous one, but it helps us to handle secure communication between services, the name resolution in the cluster because we are in a Kubernetes environment. So we don't take care of all of that. We're just using Dapr to make call between both components in a synchronous way. So it was easy to implement, not a huge amount of code, and it helped us a lot to migrate. The second one, it was to improve our analytics stack. In the past, we had a custom homemade solution, which can relate to change data capture system, but not handle deletion, stuff like that, and were too capped on the fact that we are relying on the database model. So each time we had to upgrade the model or add a new table, for example, for a new feature, we had to do the work twice. The first in the component that is responsible to gather data on tracking, and on the other hand, on our data stack that is implemented on Databricks by our data engineer and analytics teams. So it was kind of painful. The second point was that this component were in batch mode, so it wake up each X hours to gather data from the platform and send it through Kafka. And we were not able to be really reactive between the analytics and the data that happen in this platform. So we decided to go with Dapr with an easy solution where platform event, as I mentioned before, for example, you want to gather data on how amount of data are created from a specific customer on a specific field, for example, because we have many different type of personas at DataGalaxy. So you gather data from this platform, how many creation have this customer for the last week on DataGalaxy to gather what is the usage of DataGalaxy. So we are gathering this platform events through Kafka, thanks to Dapr, with a little component that is responsible to send only JSON document. So we don't have to manage our schema from the platform side. Everything is handled by the data stack part. So we are sending this on Kafka thanks to the output binding because we are not expecting something that is returned from the subscribe. We are only publishing here. The data stack is subscribing to this topic without Dapr because it's handled by a different team and they are not quite comfortable with Dapr and they don't have the need to use Dapr at all. So they subscribe on this Kafka topic and use the data to manage business tools such as Power BI and be able to help the business people to understand more KPIs, things like that, on the usage of our platform, for example. So it's quite a great improvement because we are near real time now. Every time a user do an action in the platform, we are able to track it near instantly in our data stack and see what are the indicators for a feature, for example, to see track and things like that. And the last one, which is the most important, I think, for us this year, it's the first AI-based product feature that we build on top of Dapr. The whole mechanism rely on the publish and subscribe building block. So we have the platform, which is a data catalog inside. The data catalog is filled by a company in a language. For example, you are Jagrid. You want to use our data catalog, so you will fill it in English, for example. If Jagrid becomes worldwide, maybe you will have Jagrid France that need to understand the business of Jagrid in a French term to talk the same language. The idea behind this feature is to automatically translate everything from English to French thanks to AI without manually using some translator or things like that. So Dapr helps us a lot on the publish and subscribe because we are using a mechanism on top of Kafka. So we have a first topic where we publish data in. So when we start a batch translation, so we want to translate the whole platform at a point of time, we are starting to gather data from the platform, so retrieve all metadata, all values that are translatable, for example, text, things like that. We are publishing a message per translation in a topic in. Our GCP AI cluster, which is something central, gathers the data from this topic, do his own thing, because this part is handled by the data team, data and AI team. They provide a specific way to handle stuff with VLLM, Python API, stuff like that. So they are just using our data to do the translation. And in a topic out, they are publishing the result. And we are consuming this result to translate the platform and show the result to the end user. So we can automatically, from Dapr, using this building block to perform some AI stuff and AI feature on top of DataGalaxy, which was quite good and quite impressive because we rely on all operations related to publish and subscribe, such as residency policy, dead letter queue, and stuff like that. So it helps us a lot to write not so much amount of code and have a reliable API to work on it. The feature was launched, I think, 2 months ago, and we have no error in production since 2 months on the translation part. The only error that we have is more on the business rules, but not on the infrastructure part. So it's quite a real win to use Dapr for that. So globally, what are our feedback against the user of Dapr? The pros, we can say that the API are easy to use. So there are many APIs that we can use, which are clear contract and easy. Also with thanks to the community, which many SDK available to work with it. So it's quite easy to integrate on our system. It removes a lot of complexity from code base. As I mentioned a lot, for example, the residency policy, The dead letter queue, things like that are really easy to implement. The routing also for event, because for specific event, we do some specific targeting on handler in .NET code that are directly written thanks to Dapr API. So we don't have to handle this in pure C# code. We can use a CEL language to do that. So it's perfect. On the cons part, we find kind of hard to monitor with our actual stack. We are using Grafana under the hood to do monitoring on our code base and infrastructure. And sometimes it's kind of hard to gather what is a real error that can cause trouble to production instances, or what is just normal error from the runtime. For example, a component is not ready when we restart a pod or things like that. We already had discussion with Jagrid about that, and we lead also a trial on the Jagrid conductor. I will get back to them on that in a few time. And also, it's the developer adoption. We have many subjects as a startup. We have not so many time to do it. So sometimes to make people learn new things and adopt a new technology can be kind of hard. Even if Dapr is easy to use, it's a different way of thinking because everything is provided by a sidecar. The architecture will not be the same. So it's one of our main drawback on this integration, because at the moment we are the only team that really use Dapr and try to think on our use case with Dapr. So yes, I think it's the more frustrating for us because we saw that Dapr is kind of amazing and empower a lot of things, and the fact that it's hard to move everything and everybody to it is hard, can be kind of frustrating. And now we have a question and answer session. If anybody have question on what I've said, feel free to ask.
I don't see any questions in the chat right now, but I just also need if people have questions. So you do have some time to ask your question to Tom now. For me as one of the community manager, of course, I'm a bit like triggered from developers find it maybe hard to learn Dapr, right? And I've heard before, right? There can be definitely a bit of a learning curve about Dapr.
Yeah, even if the documentation is good and API are clear, sometimes it's kind of hard to go out of standards.
Yeah, if you're used to like a certain way of working, right, then it's hard to sort of change your habits in it. Yeah, but I'm actually working on some learning materials for Dapr that will be released very soon. So hopefully, indeed, we can improve that on our side. But yeah, if you have any other concrete feedback about Dapr, or maybe some friction points, maybe not from you because you're definitely a very pro Dapr user, but feel free that your colleagues contact me or something if they have some feedback about Dapr and the onboarding. I would love to learn more about their experience or reservations. So it's good to talk about that. Yeah. Okay. But it's really cool to see that you've been up and running like pretty quickly indeed, especially with the new feature with the LLM integration. That's also
I think between the POC and the production, it passed like maybe 5 months, and we decided to go directly with production because we trust what we saw. So it was quickly easy to put in production.
Amazing. Yeah, that is really cool to see. Yeah, very nice. All right. Yeah, if there are no other questions, then I think indeed this is it. So thank you very much, Tom, for your time and for showing this.
Thank you.
Yeah, if you ever want to come back and share more details once you have like implemented more features with Dapr, you're definitely welcome to share this with us.
With pleasure.
Okay, thank you.
See you.
All right, now it's time for our next session, and that's Dapr Powered Pizza by James. Hey, James, welcome.
Hey, Mark. Thanks for having me. Excited to be here.
Yeah. As I mentioned before, right? It's dinner time here, so yeah. Whenever I hear the word pizza, I almost start to drool. So yeah.
Yeah, I've realized that myself. Actually, I'm actually quite hungry. It's the same for me. I'm in Europe as well, so it's yeah. I realized I've maybe made a terrible mistake for both of us here, Mark. But we'll see how we go.
I hope not. Okay, I've started to share your screen. You're gonna do like full demo, no slides.
Full demo, no slides. Yes,
please,
absolutely. We'll risk the wrath of the demo gods, and we will try full demos. Yeah, I thought I'd actually start off before I get into the demo of who I am, of course, and why exactly I've built what I've built. So I'm actually a developer advocate at Datadog, talking about serverless technologies more than anything. I've been there for about 6 months. Before that, I was at AWS for a few years. And one of my big frustrations when I was at AWS is that a lot of the technologies, a lot of the services that get built and talked about, a lot of the examples that get put together are kind of hello world examples, which are really useful for people getting started, right? If you're getting started with a new technology, having a little hello world example that you can just run and just build is great, but none of us are running hello world in production, right? So I've always had a thing about trying to build more real applications or more real things when I talk about things. The other side to that is that I do a lot of public speaking, a lot of talking about event-driven architecture. And whenever I talk publicly, the example I always use in all of my talks is a pizza restaurant, because I love pizza. I really like pizza. So I'd done that for a couple of years, and then I was like, okay, well, maybe I should actually just build this thing. Maybe I should actually go off and build it. And one of the other things I find now that I'm working in DevRel, and I don't know if you find this as well, Mark, but working in a more community role, you're not actually building something. And I started to feel a little bit of imposter syndrome. You're out there talking about these services and these products and these ways of doing things, and you're not actually doing it.
Yeah, I definitely recognize that. Yes.
Yeah. So that's where all of this came from. Just a bit, again, just a little bit of an intro as to why exactly I've built this thing. What I've built. If you actually go to this URL, this does actually exist, app.plantbasedpizza.net. I do actually turn this off sometimes. So if you do try and access the URL and you're watching this back and it doesn't work, that's probably because I've turned it all off to save myself a little bit of money. And if you do go and order a pizza, by the way, you're not actually going to get a pizza. And I'm sorry about that. I wish I could actually make this a physical demo as well, but I can't, unfortunately. The final thing I will say is I'm not a front-end developer. So if you do look at any of this and think, what is James doing? I am not a front-end developer. So please bear with me on that front. So all of the back end of this application is running on Azure. On Azure Container Apps. I'll come back to that a little bit later on. The other thing that in the GitHub repo that will be shared at some point, there's also an AWS implementation of this entire application. The AWS version, unfortunately, doesn't use Dapr because it's kind of hard to get Dapr running on AWS, but that's a AWS problem. So the application itself, you can come on, you can register for an account, you can log in. There's maybe 6 or 7 different microservices in the background. It's all event-driven. Most of the communication is event-driven, so it's all event-driven architecture. You can go on, you can pick a few things you want to order, pizza and chips, let's go for that. And I can go and order that pizza. And the other thing the app will do is send real-time notifications back to the front end to say where the status of the order is up to. So if I go and look at that order I've just placed, I can see the order I've just placed. I've got a margarita and some fries, and you can get a bit of history here to see exactly what was happened. So there's an order service, there's a pizza, there's a payment service that's taking the payment, and then there's communication coming back to the order service. There's also an admin panel. So if I come over, I can see all of the orders that are currently in the kitchen waiting to be prepared, and I can move these through. So I've started preparing the order, and if I come back to my actual front end where I'm logged in as a user, in a moment, there should be a notification that appears that might have already appeared and we've just missed it. So if I just move this order on again, come back to the front end, and as always happens when you risk demos in real time, things just don't work, which is helpful. So yeah, this is a very quick example of what's going on in the front end, just to kind of give you an idea of, when I start talking about some of the Dapr stuff, exactly what is happening with the actual application. I'm seeing some comments actually about no pizza, and that's sad. That is sad. I wish there was pizza. I wish I could give you all pizza, but I can't, unfortunately. Yeah, the comment about building on EKS, that's a very good point, but then you need to run EKS, right? You need to run Kubernetes. Probably another conversation for another time. So what I wanted to talk about now is what exactly it is that I love about Dapr. So when I started building this out to run on Azure, and I was working with Azure Container Apps because I didn't want to have to manage Kubernetes. I'm just me trying to build this on my own. And there's a really good integration that Azure Container Apps has with Dapr. It kind of just works natively. So that sold it to me that Dapr was something I wanted to explore and wanted to work with. So I thought I'd start with some of the really nice things that you get with Dapr for free. And where I wanted to start with that is around a lot of the observability stuff. So one of the hardest things when building an event-driven architecture is observability, is understanding how your system is working, what's communicating what with what's causing what to run, who are your upstream dependencies, who are your downstream dependencies. In a lot of cases, there's a lot of manual work you need to do to kind of link everything together and make everything work. There's a lot of manual trace propagation. There's a lot of, when you're consuming an event, you need to manually get the trace context, extract the trace context, continue the trace. So observability can be quite a tricky thing. Now, when I started building with Dapr, and I will actually caveat all of this with, I'm pretty new to Dapr. So if there's anyone who's been using Dapr for a long time and say, why are you doing that? You're an idiot, James. Please let me know. I'd like to hear that. But one of the things I really like is that you can configure a lot of the observability stuff at a global level. So here at a global level, this is for running the application locally and with Docker Compose. I can configure that I want all of my telemetry to go to that endpoint, which when you run this locally, again, all the code is on GitHub, that will all then get routed to Jaeger. So when you run the application locally, you get OpenTelemetry, you get all of that just works, and it's all going to be routed to Jaeger when this runs locally. The other thing I'm doing, so all the backend is written in .NET. I'm tempted to try and do a Rust version of it with the Rust SDK, even though the Rust SDK is in alpha, but I'm tempted to try that out as well. One of the things I really like about the way PubSub works in Dapr is the way that you can configure it just to route to HTTP endpoints. So all of the applications are split up into some kind of API and then some kind of backend worker, which is where the event handlers are. And because all of these event handlers are just HTTP endpoints, and because the way OpenTelemetry works in .NET, you can just turn on OpenTelemetry for your ASP.NET endpoints, which means if your web API receives a HTTP request that has OpenTelemetry headers, it will automatically extract them headers and automatically propagate the trace. When you combine that in .NET with the way PubSub integrates with OpenTelemetry in Dapr, the way you get your cloud events wrappers, the way you get the trace context automatically injected into your message, what that gives you in practice is automatic trace propagation. So I'm using the Datadog UI here. This is not me talking about Datadog, just a way to demonstrate this working in real time. Because this is all using Dapr and configured with OpenTelemetry, you get this automatic trace propagation. So I can see that when I said the order was complete in the kitchen service, that went through the kitchen worker. So it uses an outbox pattern to then publish the event using Dapr PubSub, which then went through to the orders worker, to the endpoint, and that was then the order prep complete event was handled. So that was the first thing I really liked, is when you start to turn on some of the OpenTelemetry features, you start to use some of the PubSub building block with the cloud event support as well. You get a lot of automatic observability, to use the term loosely. That a lot of things just happen. There's a lot of stuff that you need to do and manually extract and propagate trace context, which is really cool, as well as the cloud event support. So one of the things I always talk about when I'm talking about event-driven architecture is adopting some kind of defined event structure, event schema is really important to get it working. So the fact with Dapr, you can turn on, and I don't know if that actually works in all of the SDKs. I know in the .NET SDK, you can just turn on cloud events and you just get cloud events for free inside PubSub. So that's really, really cool. Trace propagation for free, all of that stuff. The next thing I want to talk about is the service invocation. And actually, because a lot of what I'm building here these are all microservices. A microservices architecture, it's a way of demonstrating how to do microservices on both AWS and on Azure, serverless microservices, to be very specific. So there, as well as a lot of the communication being asynchronous using events, there's also a little bit of service to service communication. So when the order service confirms an event, confirms an order, the kitchen service consumes that event and then makes a call back to the order service to actually get the order details. So there is a little bit of service-to-service communication going on using the service-to-service invocation functionality in Dapr. But what I wanted to talk about is not necessarily the service-to-service integration, but how it is that I do integration tests with these services. So obviously, one of the things you want to be doing with a microservices architecture is to be able to test each microservice independently. You don't want to be having to spin up your entire architecture to run a test, because that kind of breaks the principles of microservices. So one of the things I do when I'm testing the kitchen service is I use a service called WireMock. If you're not familiar with WireMock allows you to basically mock HTTP APIs. So you can generate mock files and you can say, if this, let's just close that. If this HTTP endpoint is received on, a GET request is received on this URL, I want you to respond with this status. So you can mock out HTTP API. It's a really useful service. There's another one called grip mock, which is for gRPC to allow you to mock gRPC as well as HTTP. Now, one of the really cool things about Dapr, though, at least from a service-to-service invocation perspective, is when I start up all of these containers to actually test my kitchen service, as well as starting up WireMock, I also register WireMock with Dapr using the app ID for, in this case, the recipe service. So the kitchen service is going to reach out to the recipe service to get all the ingredients that the kitchen needs to prepare. So because of the way service-to-service invocation works, all my application call is doing is making a HTTP call to the recipes app. If my terminology is wrong there, please shout at me, Mark, afterwards. And that's then being routed to WireMock. Obviously, when that then gets deployed into production, the code doesn't change. The code still makes a call to the recipes app, but that's then the real recipes app when that's actually running in Azure. So that was another really nice thing that I really, really liked, is that when I've had to do this in the past, you have to like dynamically sub out HTTP endpoints. You have to get the right HTTP endpoints. You have to make sure it's run on the right port, the right URL, DNS name, etc. The way you can just sub out HTTP services for another HTTP service. Really, really cool stuff. And then right at the start of this, I mentioned that this is all deployed onto Azure and Azure Container Apps. Now, because this was, I know you can run Dapr on Kubernetes. I think probably the most common way of running Dapr is Kubernetes, right, Mark? Like that's where most people are running it. Yeah. But I want to talk about serverless things. I want to talk about more things where you don't have to manage infrastructure. I'm a developer through and through. I don't like managing infrastructure. I don't like YAML files. I don't like doing any of that stuff. I like writing code. So whenever I do anything like this, I always want to run it in a way that allows me to run the application without worrying about operational overhead. That's how I think about the word serverless. Is I want to run my application without thinking about operating or managing or caring about infrastructure. I just want my code to run. So when I started looking at Azure Container Apps, that was a really nice way of doing it. If you're not familiar with Azure Container Apps, it's an abstraction on top of Kubernetes. So it is Kubernetes under the hood. And you can just define a container. You can say, I want to run this container with this much CPU, this much memory. I want a public ingress. I want internal ingress. And it just works. You just get a running application. You don't have to worry about anything else. So when you actually go and look at this application on GitHub, there's Terraform code. You can go and deploy this into your own Azure accounts if you want. There's all the infrastructure as code there to actually be able to go and deploy this. And when you actually define a container app, you are simply saying, I want to run a container app. I want to use this container image. So all the container images for all these apps are on public Docker Hub so that anyone could go and deploy this if they wanted to. So I want to run a container app. I want it to have 0.25 of a CPU core, half a gig of memory, 500 meg of memory. And I want to use this container image. And then you can also configure Dapr. So when this container app is running inside Azure, this is the kitchen service. And that then allows you to use Dapr inside Azure Container Apps. So the way Container Apps broadly works is you've got a container app environment, which is dev, staging, prod, and then you deploy your container apps inside a container app environment. So when you actually go and define a, let me find exactly where this is. When you define a container app environment, you just turn on Dapr. And sorry, I'm just trying to find exactly where that is. Here we are. Yeah. So when you actually define a container app environment, you'd create your container app environment. You'd maybe call that dev. And then you can actually define container app environment Dapr components. So here I'm defining a pub sub component that's going to use Azure Service Bus. That pub sub component is called public. And then you can define all the scopes, much like you would in any Dapr configuration file. The same again for, there's a separate pub sub component for the payment service, which only allows, kind of restricts the scopes a little bit. So you've defined your container app environment. You've turned on Dapr in your container app environment. And then you can deploy your container apps and just say, hey, this is the orders service. This is the payment service. This is the kitchen service. When you actually get into Azure, which I've got over here. So we've got the dev container app environment here. And if I go and look at the Dapr components, I can see that there's a payments Dapr component and a public Dapr component. And this is all configured to use Azure Service Bus as the middleware. Going back to what I quickly said about observability, the other thing that's really cool with Azure Container Apps and the way Azure Container Apps integrates with Dapr and OpenTelemetry is that you can just turn on OpenTelemetry inside your Container Apps environment. When you turn it on in the environment, when you run a container app, the endpoint for your OpenTelemetry collector automatically gets injected into your app as an environment variable. So obviously, I've got Datadog configured here. You could also configure application insights. You could also add a custom OpenTelemetry collector endpoint, and that'll be automatically injected into all your applications. So that defines the container app environment. And then inside that container app environment, you can define container apps. So I've got all of my applications running here. If we look at the account service, which manages logins and registrations and things like that, I can have a look at my Dapr settings, and you can see this is registered as the account service on port 88, and you've got all of the other Dapr type configuration that you would want here. So I think when I put all this together, Dapr, as everyone listening probably knows now, is a genuinely brilliant way of building applications. Like being reasonably new to it, it's such an incredibly powerful way of being able to do local dev, to be able to sub out components. This whole application uses Redis as the pub sub component when it's running locally. Without changing any application code, you deploy that to Azure Container Apps, and you're using Azure Service Bus. And you don't need to change your application code. Same for service-to-service invocation. The OpenTelemetry support, particularly for doing event-driven architectures, where you can get a level of automatic trace propagation from one service to another. And then you can run that on a service like Azure Container Apps, which is a really simple way of running containers without needing to worry about all the complexity that Kubernetes gives you. The other thing about container apps is you've got a nice off ramp then, because you're just using containers, you're just using Dapr. If you do need Kubernetes, full-blown Kubernetes at some point, then you're good to go. So yeah, that's a whistle-stop tour of plant-based pizza. The GitHub repo, I think, is in the chat, Mark.
Yes, I shared it
and if
already.
anyone has any questions, then please let me know.
Yeah, thank you, James. This was a really, really nice overview indeed, and also very complete. And you say you're very new to Dapr. So how new is new?
So I think like many years ago, when Dapr was almost first announced, I made like a couple of contributions to the Dapr SDK. This was before I worked at AWS. And then when I joined AWS and I wasn't that interested in going deep in Kubernetes, I know someone in the chat said you can use EKS on AWS. Because I was working at AWS and doing a lot of serverless things, it kind of just fell off my radar a little bit.
Yeah, sure.
And then I left AWS and I was like, right, let's have a look at Azure. Let's explore some Azure services. And then I discovered Azure Container Apps. This seems really cool. And then I was like, this Dapr thing's knocking around again. Let's go and have a look at that again. So I think I started building this Azure version probably about 6 or 7 months ago. And I will say, I suppose, that the container apps, Dapr in container apps doesn't support the full suite of Dapr functionality. So you can't do actors, you can't do workflows. So there's some stuff you can't do. I think it's secrets,
that's good to mention.
Service-to-service invocation, I think.
Yeah, no, that's good to be aware of. But the thing I wanted to highlight is that you've been successful in creating quite a broad, solid demo that touches a lot of very nice things, and not only about Dapr, but yeah, it feels like a really solid thing. So I'm definitely going to check out your GitHub repo myself. Yeah, I definitely like that you use the scopes, which are very important, right? So
that when I discovered that, I was like, because the way the payment processing, obviously, if you use this isn't going to actually cost you any money, by the way, anybody. Like, you won't get pizza, you also won't get charged any money. But that's all asynchronous, it's all pub sub. But I wanted to, obviously, you don't want to allow any service to be able to take a payment. So to be able to lock that down to say only the orders service can communicate over the payments pub sub component is
exactly
super cool. It's a really, really neat way of just making it just work, I suppose.
Yeah, that's really nice to see. Yeah, and I've heard about the WireMock, but I never really used it. So that's also definitely something I'm going to check out in it. Yeah, so Tom Flenner is also using it. So I'm new to that. So yeah, this looks very, very useful. Definitely.
I think the other one's called GripMock. Let me just double check, so I've not said something that I'm talking rubbish. But that's the one. So WireMock only does HTTP, I think, unless someone can correct me. I think the other one's called GripMock. Grip. Yeah,
I see. Yeah, I see.
Dripmock. Yeah, so that's a gRPC version of Wiremock. But yeah, it's really cool. It's really helpful service for integration testing because you can just define, and you can get quite complex. I know I quickly showed the.
You can configure all kinds of responses like default responses and paths.
Yeah, exactly.
I love this. Yeah, this is really cool. Yeah. Okay. Yeah. Well, I think it needs to be like a regular topic of this community call. Right? It's to have someone show their local environment and what kind of tooling are you using, what kind of other packages or test tools are you using to build distributed applications. Because I think, whenever someone is sharing their IDE and their code, I always see like a new tool or another thing I haven't seen yet. So I think we make this a regular topic in these community calls.
Yeah, absolutely.
Really nice. All right. Thank you very much, James. There are no other questions, but this is really a cool demo to see. So it's been shared. I'll include it in the video description as well, so people I'll link to it. So thank you very much.
Thanks for having me, Mark.
All right. Let's continue to the next part. And I'll share my screen again. Here we go. Yes. All right. So this is the last time I'm going to mention the State of Dapr survey because this is the last month that it will be open. So I mentioned this also during the last couple of community calls, but the State of Dapr survey is like the ultimate moment for you, the Dapr users, to provide feedback about Dapr. So the survey contains all kinds of questions. So how are you using Dapr? What's your technology stack? Of course, a bit about your organization, but it's also like a perfect opportunity to provide your honest feedback. What do you like about Dapr? What don't you like about Dapr? Do you think anything is missing in Dapr? If you fill in the survey this week, you even get a Dapr mug as well. So definitely fill in the survey because it's really valuable for the maintainers and for the product itself to know how it's being used and how we can actually improve Dapr. So please help us out here. Then the final section, community show and tell. There's quite some information I want to share there. So first, 2 upcoming events. This first one, the BitBash event, that's happening this Saturday. I also mentioned it last time. But Edwin van Wijk and Son Molenkamp will do a Dapr workshop, and I'm going to do a Dapr session about the workflows and the resiliency policies. And all 3 of us will also go to another event in the Netherlands called Future Tech, and we'll basically do the same thing again. So there will be another Dapr workshop by Edwin and Sander, and I will give this failure is not an option. Job execution plus Dapr is an amazing session there. And then for later this year, Nico Vermeer will do a session at .NET Days in Romania, building a distributed system with Aspire and Dapr. Of course, a very famous combination now. And a bit later in May, he will also go to NEC Oslo, again, talking about the same topic, building distributed applications with Aspire and Dapr. Some blog posts I want to mention. The first one is on Medium, simplifying microservices with Dapr and Kida. This is a subscriber-only post, though, so you have to be a paying member to read this in full. Then there's a blog post by Tong Chung about orchestrating distributed apps using Spin, Rust, and .NET with, again, Aspire and Dapr. And so Chung indeed did quite a lot of blog posts with Spin and Dapr, and now combines it with Aspire, so that's nice to see. The next one is a blog post by Rinesh, simplifying microservice development with .NET Aspire, again, Dapr and Podman. Especially the Podman part is new here because it was working with just Docker for a while, but now Podman is also supported, so he's writing about that. And the final one is testing out flexibility in microservices deployment with Dapr by David Soderlund. This is more focused about running Dapr microservices on local Kubernetes and also on other Kubernetes clusters. 2 videos that I want to highlight. The first one is the final video that Rodrigo made on the C# TV, Learning Checkpoint Dapr in Action, which is more like a summary video of all the previous editions that he did. And the other one is a French video, and that talks about Floki, which is a combination of Dapr workflows and like an integration with LLMs. Then some social messages. So there were some pictures shared from an event in the Netherlands where I spoke and also Florian spoke. Again, there was a combination about Dapr and Aspire. Some people were sharing their Dapr Holopin badges because they were either contributing to the source code or doing presentations. So also a request for the two people who just give presentation here, you can go to the Dapr community repo and submit a link to actually this video recording, and then you get a Dapr badge. And Kendall is announcing that she's very excited to be on the KubeCon stage again. And I think during the next community call, I'll do like a highlight of all of the Dapr related sessions at KubeCon in London. Some Discord stuff. If you want to please help out with testing the latest release candidate for Dapr 115, Jeroen posted in announcements, I think it was 2 days ago. So please help us out with testing this release candidate to make sure that we can get to like a full 115 version. I think that's scheduled now for the first week of February. Then because of, a lot of people are talking about using Dapr with Aspire, we have added a new channel in Discord. So it's under a new category called language integrations. So the first channel is .NET Aspire. So if you have anything that combines Dapr with Aspire, that's the place to discuss that. And in short, I think maybe in a bit longer term, we'll also add more channels there about maybe also Java and Spring Boot and other language-specific variations there. Then some other stuff on Discord. Well, some people are already testing out the release candidates for 115. So thank you, Venya, for testing and giving feedback in the Give Feedback RC channel. And thank you, Josh, for answering those questions there and providing more feedback. And thank you, George Stevens, for helping out in the state management channel with helping out some questions from LZZ. And finally, there are a lot of ways how you can engage with the Dapr community. So if you go to the dapr.io website and /community, there are a lot of ways where you can follow our news. As I mentioned, we have a new LinkedIn page that you can follow. We're also on Blue Sky. We do these community calls. If you're very active by making blog posts or doing presentations, you can nominate yourself to become a Dapr Meteor. You can collect all kinds of Dapr badges. So please visit the community page on dapr.io. And thank you all for joining this community call again. You can scan this QR code or go to bit.ly/Dapr-supporter, and then you can claim this digital badge and show that you are a community supporter of Dapr. And please share it on socials. I'd love to see the things. And if you share it, for instance, on LinkedIn, I'll make a screen capture of that and mention it in the next community call. All right. So thank you very much, everyone, and hope to see you next time. Bye-bye.